Hello everyone. In this video, we will talk about how can we obtain reflection of vector x with respect to vector a in any dimension. So let us say we have an n dimension, and then we can express vector x into our orthogonal basis, also express our vector a into our orthogonal basis. And here is a drawing of 2D, and we start with a vector x, and we have a vector a here. From the last video, we showed how can we decomposite vector x in terms of with respect to vector a. Then we get the vector x parallel to vector a and vector x orthogonal, perpendicular, vector x perpendicular to vector a. And in this video, we want to calculate the vector x star such that it has the same parallel to same parallel x component, but minus the vector orthogonal, not a vector x perpendicular component. So it should be very easy by just putting a minus sign. And since from the last video, we already know that how can we calculate this component, x parallel and x perpendicular, it should be very easy to just put a minus sign. However, in this video, we want to show a more elegant formula, more elegant expression to calculate this, which is the reflection of reflection of vector x with respect to vector a. Now I want to show you a more elegant expression to get the reflection of x, vector x, with respect to vector a, like in this figure here. So let us start with what about a inverse x a? That's a geometric product in between them. Then from the definition we have here, we have before about the A inverse, we have A divided by vector A dot vector A geometric product X geometric product A. And since in the in here they are just a number, a scalar, and geometric product you can move the scalar around. I can also move this to x a divided by a dot a, and let me make a bigger parenthesis. So it's also equal to vector a geometric product vector x geometric product vector a minus 1. So from here to here we already have a minus 1 geometric product x geometric product a is equal to a vector a geometric product x geometric product a inverse. So the order of apply inverse on the left side, on the right side is the same. And then we will first expand these two expressions. Since the geometric product from a vector to a vector, we can write it in terms of dot product and wedge product. So it will geometric product a dot x plus geometric No, not geometric product. Sorry. It would be a dot product x plus a wedge product x geometric product with a inverse. And for the dot product, we have oh no. For the dot product, they are commute, so we can just swap them. For the for the wedge product, we can also swap them, but by putting a minus sign, since the wedge product are anti-symmetry. No, anti-commute. They're anti-commute. So what we're going to have is x dot a geometric product with a inverse minus x wedge a geometric product a inverse, and that is exactly equal to what we have before, that x parallel minus x orthogonal, x perpendicular to 8. So with this mean, if we want to have a reflection, we can directly use the formula a reflect a geometric product x geometric product a minus 1, and this gives you the reflection that ax reflect on a. And remember, by definition, this is equal to x start. So this will give you the answer right away.